Today we're going to be talking about adding and subtracting rational expressions. And I always like to start this lesson by first looking at fractions. So if I want to add these two fractions, I need to have a common denominator. In order to have a common denominator, I need to multiply the 9 by a 2 over a 2 and a 6 by a 3 over a 3, because the denominators had to have all of the factors of 6 and 9. So I would get 15 over 18 plus 8 over 18 and get, when I add them together, you just add the numerators and the denominator stays the same. So again, what I was saying is that for 6, our factors of 6 are 2 and 3. For 9, our factors are 3 and 3. So for 18 has to have all of the factors of 6 and 9. Both of them have the common 3, so that's a 3. Now 9 has another 3 that I need to add in there, and 6 has a 2 that I need to add in. So if you were to break 18 down into its prime factorization, that would be 3 times 3 times 2. Now looking at a polynomial. First we need to factor those denominators. So x minus 2, x minus 1. When we factor out a 2, we have x squared minus 1. Now this factors even more. The x squared minus 1 is going to factor to x minus 1, x plus 1. So each one of these is considered a factor. So our least common factor would be 2. Both denominators have an x minus 1. This first denominator has an x minus 2 that the second denominator would need. And we have an x plus 1 that we would need. So that's how we get our least common denominator. Now looking for our least common multiple of monomials. Monomials, one term. Okay, so we have to break this down. We have to break down 15 a squared bc cubed into 15. Well, that is 5 times 3, a times a times b times c times c times c. When we're looking at 16b to the 5th, c squared. Well, 16 is 2 to the 4th power. And then I have b 5 times. And I have c 3 times. I'm sorry, 2 times. Lastly, for 20, a cubed c to the 6th. We have a 4 times a 5. Well, that's a 2 times a 2 times a 5. We have a to the 3rd and c to the 6th. Now for your least common multiple, you have to pick essentially the highest power. So the highest power of my 2's is 2 to the 4th. That's going to also take care of these 2's. This has a 5 and this has a 5, so I need a 5. So it's 2 to the 4th times 5, and then we need a 3. Again, you're always picking the highest power. So look at your highest power. We have a to the 3rd is the highest power. And that takes care of these two a's here. We have b to the 5th power. And then we have c to the 3rd, c squared, and then c to the 6th. So you always pick the highest because your denominator or your multiple has to have all of the factors. So multiplying 2 to the 4th times 5 times 3, we get 960. A to the 3rd, B to the 5th, C to the 6th. Next example. You have to factor each one of these. So x to the 3rd minus x squared minus 2x. Remember that what you want to do first is always factor out the common multiple that's in each one. So then I have x squared minus x minus 2. And that's again factors to x minus 2, x plus 1. Okay, this other one, x squared minus 4x plus 4. That's a perfect square trinomial, so that's going to be x minus 2 times x minus 2. Now again, your least common multiple has to have everything that's in both denominators. So I have an x in this denominator. I think about them as denominators, honestly. I have an x here, so that's part of my least common multiple. I have x minus 2 in this one. I also have x minus 2 in that one. But I actually have 2x minus 2, so I need to take that higher multiple. And then I also need to add in this x plus 1. So that's our least common multiple. Now, honestly, I think that's a little bit harder than when we're adding. Okay, so when we're looking at these, and we have 5a squared over 6b plus 9 over 14a squared b squared, we need to get the common denominator. So between 6 and 14, what's the smallest multiple between 6 and 14? Well, that's going to be 42. So I'm going to need to multiply by 7 over 7 on the left and by 3 over 3 on the right. Now, this denominator has an a squared. This denominator has no a squareds. So I need to multiply by that a squared so that now I would have an a squared on the bottom. And then this has a b, this has a b squared, so I have to take the higher of those two exponents. So I multiply by b over b, because when I multiply b times b, I will get a b squared. So our common denominator ends up being 42a squared b. I multiply the numbers on the top together, so I get 35 a to the 4th b. Our other denominator, oh, that should be a b squared, because I had b times b. 9 times 3, 27. So then we have 42a squared b squared, and then I have 35 a to the 4th b plus 27. Okay. Again, what you want to do is you want to make sure that you factor. So let's factor each one of our denominators. I have a common factor, GCF, I can factor out. Now you can't cancel anything with these unless something's going to cancel on the top and the bottom. Here I have a 6 that I can cancel out, and this is going to be x minus 5. Okay, now let's look at this. They both have an x minus 5, so I don't need to do anything with that. This denominator has a 3 as part of my factor. This denominator has 6. So I need to turn this 3 into a 6. So I need to multiply by 2 over 2. And it doesn't help you to factor out the numerators because you're eventually going to be subtracting anyway. So don't worry about factoring out anything in the numerators. So if I multiply by 2, remember this is a quantity that I need to distribute to. And keep that denominator unfactored. Okay. Now, remember your denominator, keep that factored. Now you have 2x plus 20 minus 3x minus 15, because I distribute that negative to both terms. Now we simplify out the numerator. 2x minus 3x is a negative x plus 5. Now, something that's kind of interesting here. Notice how this x minus 5, and I have negative x plus 5. If I factor out a negative from the top, now, those can cancel. Remember, they cancel to be 1 and 1, so I'm left with my answer being a negative 1/6. Keep in mind, this is a rare occurrence where things are going to cancel once you factor. Okay, so keep in mind, you're not going to be doing this whole factoring thing a lot. Today we're going to be talking about simplifying complex fractions. And there's really two different ways that we can go through simplifying these. I don't care which way you use. I'm going to use one method for one method for the next one, and then I'm going to show you the third example for in both ways and see how they differ and they kind of make your life a little bit easier. Okay, the first method, or at least how I think of it as the first method, combine the fractions on the top. So I need a common denominator. My common denominator is a times b. So I'm going to multiply that by b times b. I'm going to multiply that times a times a. On the bottom, again, do that same thing. My common denominator is b, so 1 can become b over b. So now, on the top, and I'm going to make a really big division symbol. On the top, I have b over ab plus a over ab, which that is going to simplify to b plus a over ab. Now in the bottom, we have 1 minus b over b. So we have 1 minus b over b. Now this is a shout out back to the first section we did. B plus a over ab. Keep the numerator, change your sign to multiplication, find the reciprocal of the bottom, multiply by the reciprocal of the bottom. The b's cancel, so we end up with b plus a over a times 1 minus b. And that's completely simplified because I can't factor anything out and none of the factors on the top cancel with factors on the bottom. Now I'm going to do this one a different way. Okay? So the second way to do this is to multiply by the least common multiple of your denominators. So look at x, look at y, and look at x. What's the least common denominator between each one of those? And you're going to multiply the whole numerator and the whole denominator by that denominator. So if you multiply by xy, multiply by xy. when I take and I multiply this xy times the 2 over x. So I have xy times 2 over x minus xy times by a1 all over. Now I have 1 over y, and I'm taking and I'm multiplying xy times that. And then we have 3 over x, also times by that xy. Now take and cancel. The x's cancel. So this term simplifies to 2y. This second term, nothing cancels, so I'm just left with xy all over y. The y's cancel, so I'm left with an x minus the x's cancel, 3y. I could factor out a y from the top. Nothing factors on the bottom. I just did that factoring to see if anything canceled. And that would be our final answer. So when you multiply by the least common denominator, notice how those fractions go away. It's actually, in my opinion, a little bit less work. But you have to really understand those least common denominators and make sure you're multiplying every single term by that same thing. Okay, our third one, and I'm going to do this both ways. Okay, you only have to write down one of the two ways. Write down the way that you prefer. Okay, this one I'm going to do the longer of the two ways. Since my fraction on the top, I just have a fraction on the top, we are good. So I don't have to simplify that anymore. On the bottom, this denominator needs a 3x plus 1. This denominator needs an x over an x. So my common denominator on the bottom is x times 3x plus 1. On the top, we have a 3x plus 1 plus a 3x. So we keep the numerator to the same. Change your sign to multiplication and flip the denominator. And I'm going to simplify here. 3x and 3x is 6x plus 1. Now, because you're multiplying, you can cancel along your diagonals. 3x plus 1's cancel. So I'm left with an x times the quantity x minus 2. I leave things factored to make sure I've canceled everything out appropriately. And we get x times x minus 2 over 6x plus 1. So that's by combining your fractions into one fraction first, then changing like we did in section 1. Now method 2, multiplying the top and bottom by the least common denominator. So the least common denominator is x times 3x plus 1. So you need to multiply each one of these terms by x times 3x plus 1. X times 3x plus 1. So on the top, 3x plus 1's cancel. I've just left with an x times an x minus 2. On the bottom, the x's cancel. I have a 3x plus 1. In this second term, the 3x plus 1's cancel, so I have another 3x. And notice how we get the same thing either way. Okay, so we're getting the same thing no matter which way we do it. Again, I think this one's a little bit shorter. It's less steps, but you need to remember to multiply the common denominator to each one of the terms.